Assalamualaikum warahmatullahi wabarakatuh. Today, I would like to introduce to you about the galvanic cell. So today, me and my friends we would like to tell you about this experiment. Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Azim Firdaus bin Arifin, and today I would like to introduce to you about the introduction of galvanic cell experiment. So today we will explore about the galvanic cells that consist of two crucial parts, which is the anode and the cathode. The anode is where oxidation occurs, and the cathode is where reduction takes place. We have also looked into reduction potential, a key concept that helps us predict which substance will serve as the anode or cathode in a galvanic cell. So next we will talk about the concentration. By altering the concentration of the electrolyte solution, we can manipulate the voltage and the current produced by the galvanic cell. It's a powerful way to control the cell's performance. Lastly, we will explore the nurse equation, a valuable tool in our kit. This equation allows us to calculate the voltage of a galvanic cell at a different concentration, providing us with insight into how the cell behaves under verifying condition. As we can look on the figure, that is an example of the galvanic cell. For this experiment, uh, that have four objectives. Firstly, to measure the relative reduction potentials for several half cells, which is redox couples in a galvanic cell. Secondly, to develop an understanding of the movement of electrons and ions and cation in galvanic cell. Next, to study factors affecting cell potential. And lastly, to estimate the concentration of ions in solution using the Nernst equation.
Okay, now I will present to you about methodology. Our methodology divided into three, which is first reduction of potential, second is about the concentration, effect of concentration, and the third one is about Nernst equation. Okay, we move to the first part, which is reduction potential of redox couple. First thing, we need to collect the electrode solution and equipment, where we set up 3 beakers filled with 0.1 solution of zinc nitrate, copper nitrate, and ferrum 2 sulfate. We also took strips of copper, zinc, and iron metal. We polished them with sandpaper and rinsed them with the ionized water. Then we placed the strip in their respective ion solution as electrode. Second, we set up the copper or zinc cell, where we set the experiment by placing a copper strip in the copper nitrate solution and a zinc strip in the zinc nitrate solution. Then we took a piece of filter paper, roll it up, and wet it with 0.1 potassium nitrate solution. Then we insert one end of the filter paper into each of the beaker, and the filter paper acted as a salt bridge. Finally, we connected one electrode to the negative terminal of the voltmeter and the other electrode to the positive terminal. Then finally, for the third step, we determine the copper or zinc cell potential, where the positive cell potential was read and recorded. Then the metal strip that served as the cathode and anode was identified. So for the fourth step, we repeat for the remaining cell, where we repeat for all possible galvanic cell that can be constructed. Alright, moving on to the effect of concentration, which is part 2. First, we do the effect of different molar concentration first, where we set up the galvanic cell with two parts. In part A, we use a 1 molar copper to sulfate solution and a 0.01 molar copper to sulfate solution. We took a shiny copper electrode and dip it into each solution. Then we connect the two redox couple with salt bridge. Finally, we figure out the cell potential and the reaction equation of each electrode. And for the second one is the effect of complex formation, where we pour 5 milliliter of 6 molar ammonia into the 0.001 molar copper to sulfate solution until any solid that form dissolve again. And then we keep a close eye on any changes happening in the half cell and the cell potential. Alright, now moving on to the part 3, which is the last part of this experiment where we do the nurse equation and an unknown concentration. First, we need to prepare the diluted solution where we took 1 milliliter of 0.1 molar copper nitrate and carefully pipette it into 100 milliliter volumetric flask. Then we use deionized water to dilute it until it reach the calibrated mark on the flask. And then we label this dilution as dilution 1. Then we repeat the same step for the next three dilution and we label into dilution 2, 3 and 4. And for the second step, we measure and calculate the cell potential for solution 4, where we set up the experiment just like before, but using a small beaker. Then we prepare a salt bridge to connect the redox couple. Also, we went ahead and determined the cell potential and the reaction equation at each electrode. And for the third step, we repeat the second step for the solution 2 and 3, but every time we repeat the solution, we must use a new sort bridge. And then for the fourth step, we plot the data where E cell measured and E cell calculated was plotted versus log CO2 plus on the graph paper for the four concentration of copper nitrate. And then the fifth step, for the step number 5, we determine the concentration of the unknown where we obtain a copper nitrate solution with an unknown copper ion form, the lab technician. Also, we wasted no time and set up a galvanic cell. Then we dove right into the determine the E cell potential, and the concentration of the unknown copper ion in the solution. Alright, now I will present to you about our result and data. For the first part, which is reduction potential, in our galvanic cell, which is the first pair, which is copper and zinc, we get the reduction potential 0.43, which the anode is zinc and the cathode is copper. And for the second pair, which is copper and ferrum, we get 0.77 volt, and here the anode is ferrum and the cathode is copper. And for the third pair, which is zinc and ferrum, we get 0.22 volt, which is our anode here is zinc and our cathode here is ferrum. Alright, now we go to the second part, which is effect of concentration. Okay, effect of concentration for the first couple, which is copper, we can first we calculate the reduction potential beforehand, and here we can see the large difference between the reduction potential that we measured and we calculate. Where our calculated one, which is where we do the experiment, is 0.31, which higher than the measured one because maybe while we doing the experiment, the concentration is higher that make the overall system overall process is higher and higher in electron flow. That's why we get the percentage error 54.48%. And for the second one, which is ferrum, this is good because their reduction potential is almost the same, and here the error percentage is only at 8.51%. And for the last one, which is zinc, this also a major difference, but it is only a slightly difference, which is the measured one is 0.57, but our calculated one is 0.47. That give us the percentage error in about 21.28% only. Alright, we move to the third part or the last part, which is nurse equation and the unknown concentration. Here we can see that after we calculate the concentration of copper nitrate, we can see that it is decreasing in value of concentration. And after we using the Nernst equation to calculate the E cell, we can see that the solution from 1 to 4 is slightly increased, which is from solution number 1, the E cell is 1.1 volt, and for the second one, for the second solution, we get 1.04 volt, and the third one we get 0.998 volt, and the fourth one is 1.007, which is slightly increased. And we can tell that if the when the E cell is increased in galvanic cell, it tells us that the cell is operating more efficiently and can deliver a strong electric current, where this can be advantageous in various applications.
So, my name is Mohammed Shamizan. So, I will cover about discussion. So, for discussion is, we use a different method and they are ion to generate electricity through a redox reaction. The cell have anode where is oxidation happen and cathode where reduction happen. The electrode are connected by a wire allowing electron to flow. A salt bridge or porous barrier is used to maintain electrical naturality and allow ion movement. Or the measuring the potential difference between the electrode help determine the cell potential. Changing the redox couple effect the cell potential and overall reaction. Different redox couple have different standard reduction potential. The next equation help calculate the cell potential under non-standard condition. So, the formula is E cell equal E cell tolak 0.0592 over n time to the log Q. In the experiment, we aim to determine the reduction potential for different half cell couple, effect of concentration in change cell potential, and using Nernst equation. So, for the conclusion, we managed to measure reduction potential between copper and zinc, copper and ferrum, and zinc and ferrum, which is positive 0.43, positive 0.77, positive 0.22, respectively. We also study electron and ion movement and explore factor affecting cell potential, which is in this experiment is different concentration we measure E cell with 0.304 volt. The next equation help estimate ion concentration. The experiment depend our understanding of galvanic cell. That's all from us. Thank you.